Comorbidity 2. Often in observational studies, you want to be able to compare how similar two populations were at baseline. One method of doing this is to summarize all the diagnoses that occurred in these patients prior to the onset of the observational period. For example, you might want to know all the diagnoses of the inpatient admissions. You might want to know all the diagnoses of the ED visits. You might want to know the diagnoses of the outpatient visits or ambulatory surgery. All these diagnoses prior to the hospital admission make up a score, a Charlson comorbidity score, that allows you to summarize how sick those patients were prior to the admission. Let's proceed. Let's look for comorbidities in a group of patients admitted to the hospital in April 2016 whose age was between 65 to 70. I've already built this cohort, and so I'll just select it from the drop-down menu, and I'm going to name it just admit. Now we're going to go to the methods section, and I'm going to add the method, and the method type is going to be comorbidity, and we're going to call this with blackout, and you'll see in a minute why. So immediately you get the standard racetrack, and you can see we're starting and going back in time. We're going to collect all those diagnoses that occurred prior to the index date. Now the way it's set up right now, it's actually capturing the index date itself, and since the index date is admission, you do not want to get those diagnoses from this admission because you want to get those diagnoses that preceded the admission. So in order to force that issue, you create a one-day blackout, and this now will look from one day prior to the index date, or one day prior to the admission, going back 180 days. Now you are able to change this, 180 days, a year, 2 years, or build it on some other end date that you've uploaded. But in this case, we're going to leave it at 180 days. The outcome are a group of clusters of diagnoses, sometimes ICD-9, sometimes ICD-10, that make clinically cogent clusters. Congestive heart failure, peripheral vascular disease. And now we're just going to run it. And what Looking Glass is doing is going back in time. It is collecting all those diagnoses that occurred more than one day before the index date, and it's summarizing them into clusters of yes or no, 0 or 1. The actual runtime is about 0.05 seconds per member of cohort. If you do not get a response by that time, there's a trick. You go back home. Okay. It's running in the background. And then you go back to Study Designer. You open it up. And you open up the study. The results have actually been completed. You can see a check off run. You go to the methods section. You have your result here. You notice that you have your clusters: metastatic solid tumor, AIDS, HIV, Charlson score, renal disease, 0, 1, 0 is no, 1 is yes, any malignancy, 1 is yes, 0 is no. It then calculates a Charlson score, which assigns to each of these clusters a particular weight and adds them up. There is an age-related risk, which your manual will tell you is 1 point for every 10 years over age 40. And then you add those two scores together and you have what we call Charlson with age. This is a severity metric that you can use to adjust your populations with. In addition, there is a column called estimated percent of 10-year survival. This is a very old and probably unreliable index, but gives you some notion of how sick those patients actually are. Now you can export the data into an Excel spreadsheet. Left click on Data File. You'll open it up. all self-documenting, like all other studies in Looking Glass. And you actually have the data, which has some interesting information: census tract, census block, longitude, latitude, if you use identifiers. And here are the clusters, 0, 1 for each one, the overall Charlson score, age-related risk, Charlson with age. Now you can go back to the study and you can build another study if you'd like, and this time do comorbidity without blackout. So instead of having 0 to 1 day, make a 1 day blackout, you leave it just at 0. What this now does is it captures not only the diagnoses 1 day to 180 days, but it also captures the diagnoses of that original admission. And when you create the spreadsheet for that and you output it, and you look at congestive heart failure of those in the no blackout period, and if you compare the indicator variable for congestive heart failure in the no blackout group to the indicator variable for congestive heart failure in the blackout group, what you will discover is there are a large number of patients who have now suddenly developed congestive heart failure. In fact, 59 patients, when you don't black out, have congestive heart failure. Here's 1 in the no blackout group, and here's 0 in the blackout group, meaning that you've now captured the congestive heart failure of the index admission. So you've got to be very careful in telling Looking Glass whether you do or do not want a blackout period. My recommendation is, if you're doing an analysis looking for comparability at baseline, you do not want to capture that original hospitalization. On the other hand, if all you want to do is capture the original hospitalization, if all you want to do is get the original hospitalization comorbidity scores, the comorbidity scores of that hospitalization and nothing else, what you would basically do is you'd go into your methods section, show criteria, and now have no blackout period, and go to an end date which is 1 day. So now you'll be looking at a study that's going to capture the index date and go back 1 day. This is a way to capture what's called the classic Charlson score, which was to look at the score of severity of disease during the original hospitalization. So if you want to look at the original hospitalization, you have no blackout period, go back 1 day. If you want to look at the comorbidity score prior to the hospitalization, you set it a blackout day of 1 day, and you set your endpoint at 180.